For other videos and problems like this for Intro to Stat Methods for Business, you can go to Sarai Studies, link is in the description box below. In this video, we're going to be learning about multiple linear regression. Now, the only difference between linear and multiple is that in linear, we only have one x column. In multiple, we have more than one x column. The story here is that we have students, and these are their grades. This is our y values, or y column, and then these are the hours that they spent studying to get those grades, and then their gender. If it's a boy, it's B. If it's a girl, it's G. The goal is always to come up with a model, an equation that we can use to predict future y values. In this case, we want an equation to predict future student grades. The way we do that is we go to data, we go to data analysis. If you don't have that button, look at the link in the description box below and I'll show you how to get that button. Click on regression, click on OK. Our y range is our y column, so we select our y column including the labels, so we check on labels. And then our x range for multiple linear regression is all of the x columns. And then we would say, okay, I want the summary output to be over here. And then we click OK, and then we see, wait, input range contains non-numeric data. So we can't get a summary output because there is some categorical data. There's data that's not numbers. So in order for us to get a summary output, in order to get to the equation, we need all our data to be numerical. So the goal here is to convert all of this categorical data to numerical data. What I like to do is I like to take the name of the column that's categorical. So in this case, it's gender, or also known as a second x variable. And I like to just use this notation and write down all of the options that I have within that column. So the only options I have is boy or girl. And so the idea is that for each option, we're going to create a column, something like, is it a boy? Is it a girl? And for each one, we're going to go through and say, is it a boy? True. Is it a boy? False. Is it a boy? True. But we can't just write true and false, true and false. We have to find a way to convert those true and falses into numbers. And what's the way to do that? Zeros and ones. So what I like to do is for each option is say, if it is true that it's a boy, then return 1. If it is false, then return 0. If it is true that it's a girl, return 1. If it is false, return 0. And we can do that for both columns, but at the end of the day, there's this rule that if you have 2, then you only need to make a column for 1. So in that case, personally, I always just cancel out the last one and I don't make a column for that one. Another example, if this column was colors of t-shirts instead of gender, and you had different options like pink, blue, and green, then if you have 3 options, then you're only making 2 columns. And I personally just make the column for the first 2. I just cancel out the last one. So in that case, we're not even going to do a column for the girl, so we can get rid of that. So I always like to make the column names the same thing as options, so B. And again, we don't need the girl. That's the rule we abide by. And so we're just going to go through and we're going to say, if this is the same as this, then return 1 if true, 0 if false, because those are the rules that we defined right here. Click enter. And we want to drag it down so it applies to everything. We want to make sure that if we are dragging across the rows, we want to lock the opposite the columns. And so the columns, remember, are the letters. So we're going to lock the D, and then we also want the B for all of those rows to stay the same. So we're going to lock that cell by locking both the column and the row, and then we can drag that down. And then that's it. Now we turned this column into numerical values, and now we can just use it in our summary output to get the equation that we can use to predict future y values. But to do that, make sure that you just move this to the side because we're not going to use it anymore, and so we can have all our numerical x values together. Now we're going to go to data, data analysis, click on regression, click OK. Our y range is going to be our y column. I'm including the label, so I'm going to check labels. X range is going to be all of our numerical x values, and then output range is where I want it to go, and then click on OK. Now this is our summary output, and we can use this summary output to come up with an equation or a model that we can use to predict future y values, future student grades. So remember that y hat, our predicted future y values, is going to be equal to baby, but we change that to be bow b, and then we separate by a plus sign and know that bow is the intercept, b is the slope, and so this is the slope for the first x variable. And because this is multiple linear regression, now we have another slope because we have a second x variable. So here we call this slope 2, and this would be slope 1 on the first x variable, and then so on and so on. In this case, this is our bow, this is our b1, and this is our b2. Slope 1 for this column, and then our slope 2 for this column. So in our case, y hat is equal to our bow, which is our intercept, plus the first slope of this column, hours, so that's going to be this, times the variable, which is hours, and then plus the second slope for this column, boy, which is this, times the second variable, which is this. And that's our model. This is our equation. Now, instead of learning how to interpret this, let's just learn how to answer questions using this model, and then we'll get to the specifics of interpreting. First question is asking, what is the estimated grade or the predicted grade for a student who is a girl and has studied for 4 hours? So no, if a student is a girl, that means that it's not a boy. And so if it's not a boy, then the b variable is 0, meaning that this just becomes 0, x2, 0. And so 0 times this number just cancels out to be 0. And so essentially we're just left with this. Here we have this plus this, and then the girl is studying for 4 hours, so the hours goes here. So y hat is equal to this plus this times 4 hours, because the girl spent 4 hours studying, and that's it. And we don't include this again because if it's a girl, that means that it's not a boy. So b is 0 because we defined it as such. We said that if it's not a boy, then it's 0. And so that cancels out with this coefficient, and therefore we don't even need to involve this in the calculations. So the answer to number 1 is 73.0577. The next question is asking, what is the estimated grade for a student who is a boy and has studied for 7 hours? So remember that if it is true that a student is a boy, then boy is 1. So in that case, boy here is 1, and so that means we are still going to multiply by this number, and the amount of hours that the boy spent studying is 7. So the hours is 7, and we're still multiplying by this number. The intercept remains the same, and so y hat is equal to this plus this times this plus this times this, and that is your answer. All right, let's get into interpretation. So the first thing you have to know is the baseline. So recall that the baseline is just whatever option you canceled out, whatever option you didn't make a column for, a dummy variable for. In that case, it's the girl. Also recall that if it is true that the x2, the gender, is a boy, then we return 1. If it is false that it's a boy, we return 0. False that it's a boy also means it's a girl by default. So if we interpret the first slope, which is over here, which is attached to this variable, that means that we have to hold all other variables constant. In this case, the only other variable is x2, the gender, if it is true as a boy or not. So the only way that this number can exist or be part of the equation in the first place is if this is 1, because if it was 0, the other option, then it wouldn't exist in the first place and it wouldn't be part of our equation. So this is 1, so it has to stay 1, so it has to stay a boy. So holding the fact that this is a boy constant, and also this being constant already by default because it is a constant, then we say for every 1 hour the student spends studying, if it is a boy, the grade is expected to increase by this amount of points in comparison to the baseline, which is a girl. Now if we interpret the b2, which is the second slope right here attached to the second variable, we say, okay, holding all other variables constant, all I mean is holding x1 constant, the hours studying constant. If a student is a boy, and I say it's a boy because again, this number can only exist if it's a boy, because what is a boy? 1. So if we put 1 times this, it's this. If we put 0, then it cancels out, and then we don't even have that number in the first place. So if it is a boy, holding studying hours constant, his grade is expected to decrease because of the negative by 7.3333 points, more than a girl. Because if it's a girl, then x2 is just 0. Then there would be no decrease in the first place because this number doesn't exist. So this number just cancels out, and we're just left with the rest of the equation. Now interpreting the intercept, that just means that all x variables have to be 0, so study hours has to be 0, and this also has to be 0. So if x2 is 0, that means that it is false that it's a boy, so aka it's a girl. So we say if the student spends 0 hours studying and is a girl, because that's the only way that this is 0, and all this cancels out, then we're just left with 44.6 if you're wrong. And that's it for this video. I'll see you in the next.